Hi, sixth graders, this is Mrs. Gall. Today we're going to start talking about one-step equations and inequalities. Grab your notebook, get this title at the top, and press play when you're ready to continue. What number could the variable be to make the equation true? Let's start by looking at the first example. X minus 2 equals 7. What must x be? Well, I need to think about what number minus 2 gives me 7. That would be 9. What about y in our second example? If y plus 10 equals 14, what must y be? Y must equal 4 because 4 plus 10 gives us 14. What about the third example? 5 times m equals 35. What must m be? Well, 5 times 7 is 35, so that must be a 7. And then n divided by 3 equals 11. What number divided by 3 would give us 11? 33. Look at our answers, and then look at the equation. Do you see a pattern or rule you could use to solve an equation or an inequality? Well, look at this example. We had a 2 and a 7 in our problem, and our answer was 9. How could we get a 2 and a 7 up to 9? Well, we could add 2 to that 7 to get to 9. What about in my second example? How could I get a 4 with 10 and 14? I could subtract 10 from both sides to get 4 because 14 minus 10 is 4. What about 35 and 5? How could I get 7 with that? I could divide 35 by 5 to get 7. And how could I get 33 from 3 and 11? I could times. So what I'm noticing is I'm using the opposite operation. Right here was division, but in order to get my answer, I did the opposite of dividing. I multiplied to get there. Same thing here, but this was a multiplication problem originally. So to get to 7, I divided, the opposite of multiplying. And the same things applied here. To get to 9, I originally had subtraction, but when I added, that got me to 9. And here, this addition problem, I had to subtract to get to 4. So today we're going to use inverse operations to solve our equations and inequalities. Inverse operations undo one another. So whatever is done to one side of the sign, we have to do to the other. Let's look at some examples. It's very important to know that as you move forward in math, these problems are going to get more challenging and more difficult, so we want to make sure we're practicing showing our work now on our 1 and 2 step examples, so that when you get to multi-step, you feel very confident with that process. Even if you know you can solve these in your head, showing your work is just as important as figuring out what your variable equals. Go ahead and write this example down. X plus 11 equals 34. Right now we have x plus 11, so we want to use the inverse operation of adding to get x by itself. What's the inverse of adding 11? Subtracting 11. So we're going to do that to both sides of the equation. When I subtract 11 over here, it just gets rid of the 11, so all I'm left with is x. And on the right-hand side, we're going to get our answer after we take 34 minus 11. What is 34 minus 11? 23. That means if we went and put a 23 in for x, 23 plus 11 should equal 34, and it does. So my answer for x is 23. What does that mean? It means if I go and replace x with a 23, that equation should be true, which it was. Let's try this one. Y minus 17 is greater than 13. We're going to use the same process. We're going to go on the side that has our letter, and we're going to use the inverse operation to get rid of the number that's over there. So right now I see minus 17. What's the inverse of subtracting 17? Adding 17, so we're going to do that to both sides. When I add 17, that cancels out my 17s on the left, so all I'm left with is y. And then 13 plus 17 is going to give us our number answer, 30. This means y is greater than 30. What does that mean? That means you could plug in any number that's greater than 30 and place it here for y, and this inequality would stay true. We can't choose 30 because it doesn't say greater than or equal to, but anything larger than 30. Let's pick a number to try that's larger than 30. Let's try 37. If I take 37 minus 17, that should be greater than 13. Let's see if it is. I know 7 minus 7 is 0 and 3 minus 1 is 2, so I would get 20. Is this true? Is 20 greater than 13? Yes, that is true. So that means my inequality worked. Let's move on to multiplying and dividing. This problem says 4 times n, or 4n, is less than or equal to 28. On the side with the variable, what's the opposite of timesing something by 4? The inverse of multiplying is dividing. So we're going to divide both sides by 4. 4 divided by 4, that cancels out. We get 1n, which is the same thing as n. 28 divided by 4 gives us 7. N is less than or equal to 7. What does that solution mean? That means any value that's less than or equal to 7 could work in replacement of n. Let's try something. Let's pick something that's less than or equal to 7. Let's pick 5. Let's go back into our problem and plug in a 5. 4 times 5 should be less than or equal to 28. 4 times 5 is 20. Is 20 less than or equal to 28? It is. It's less than. So my inequality makes sense. K divided by 5 equals 6. How are we going to get k by itself? Well, the inverse of dividing by 5 is multiplying by 5. So we're going to do that to both sides. That cancels out my 5's on the left. I'm left with k equals 6 times 5, which is 30. What does that mean? It means if I plug a 30 in for k, 30 divided by 5 should equal 6, and it does. So notice on equations, when we have an equal sign, only one value is going to work for our variable because it's telling us exactly what the value for k should equal. But on our inequalities, we have multiple answers. They just have to make sense with that inequality sign. So it can be any number less than 7 or equal to 7. Because inequalities have infinite solutions, equations usually just have one solution. How are equations and inequalities similar? How are they different? We solve equations and inequalities with pretty much the same process. Those answers just look different because one will have an equal sign, an equation, and that means we have one answer for an equation. Inequalities have an inequality sign, which means we have infinite solutions for our inequalities. Let's practice a few on your own. Press play and try each one on your, or press pause while you try each one on your own, and then press play when you're ready to hear the answer. 23 plus x equals 40. This one, the order was kind of reversed, but pay attention to the number that's on the same side as your variable. Right now I see a 23. I don't see a plus or minus in front of the 23, which tells me it's a positive 23. So to get rid of it, I'm going to do the opposite of a positive 23, and I'm going to subtract or use a negative 23. That cancels out my 23's on the left. I'm left with x equals 40 minus 23, which is 17. If I plugged in a 17 here, my answer should be 40. 23 plus 17 equals 40. Pause and try this one on your own. Press play when you're ready to hear the answer. 5 times c is greater than 100. The opposite of timesing by 5 is dividing by 5. That means c is greater than 20. What does that mean? It means any value over 20 would work in replacement of c. Try this one. 7, I'm going to write it this way, is less than y over 2. You guys, before you try this one, what does a fraction bar mean? It means to divide. So think about what the opposite of dividing 2 would be. Press play when you're ready to hear the answer. The opposite of dividing by 2 is timesing by 2. So I'm going to times both sides by 2. That leaves me with y. We have the greater than sign facing the y because it's the open part of the sign. And then 7 times 2 is 14. So we could say this as 14 is less than y, or if I read it the other way, y is greater than 14. So I could plug in anything that's larger than 14 and this should stay true. Let's try it. What's something that's larger than 14? Let's go with 16. So let's plug that into the original inequality. What is 16 divided by 2? 8. Is this true? Is 7 less than 8? Yes, so I know my inequality works. Last one, try this one on your own. Press play when you're ready to see the answer. 7 times g is 63. Opposite of timesing by 7 is dividing by 7. I get g equals 9. All right, you guys, that's all I have for you today with one-step inequality practice. Please remember, showing your work is just as important as providing the answer. Check in with your teacher if you have any questions.